Hey there, welcome back to the Database MCP series. This is part 5 of this series, and today we will focus on expanding our MCP server with additional tools and safety mechanisms by implementing three essential components. First, validation testing tool to demonstrate data integrity features with test cases. Second, update database tool to safely modify existing records with parameterized queries. And then delete database tool for multi-layer deletion with three safety modes. Before we dive in, let's quickly recap where we have been. In part 1, we created and set up the databases that will be used by our database MCP server. In part 2, we began building the database manager by implementing logic for stabilizing connections to different types of databases, adding functionality to check whether the database connection is active, retrieving the structure of any table so that later operations can use that information for validation. In part 3, we strengthened the safety and reliability of our database operations by implementing validation and cleaning mechanisms in our database manager. In part 4, we built the MCP tools by implementing three essential components. Query database tool to execute select queries on any database. Insert database tool to insert records with data validation. And connection pool management to manage database connections efficiently. Let's jump straight into the code and start building these new tools. And now we will create another tool called test validation examples. With the help of this tool, we will identify whether the operations that we are performing on the database are valid or not. So let's do that. We will write the comment saying test function to demonstrate the validation, and then we will write the decorator MCP tool, and then asynchronous define test validation examples database path, which should be of type string, and its default value. Let's say it is this in our case, and then we will write string. Now we will write the talk string saying test validation with various examples to show how it works, and then we will write examples, and this creates an empty list called examples that will store the test results, and then we will define a variable called test cases. This will be a list of dictionaries, and each dictionary will be referred to a single test case. So here we will write name. So we can name it anything. So let's say valid data, and in data we will write name John Doe, and then we will write an email, and this email will have the value john at example.com. Then we will have age, which is set to 30. So we can ask in the prompt to insert this data into the table, and if this record is already present, then the operation will be failed, and if it is not present, then this value will be inserted into the table. Now let's create the second test case. We will write name. We can provide any name, in this case empty name, and this should fail because we will provide the empty value to the name variable. So we will write should fail. Then we will write data which corresponds to name, and this name will have empty dictionary as a value. Then we have email, and this will have test at example.com. The age will be, let's say, 25, and we can simply copy this. Let's add the semicolon, sorry, comma here. So this is correct now. And then this is the third one. So what we will do is that we will write null name, and this should also fail. The name should be null, which corresponds to null. Then email should be fast to. You can keep the age as it is. And then we will write here missing required field, and this should also fail. So here we can only provide the age. And in the last one, we will write white space only name. So here we are only providing the white space as a name, and then email should be, let's say, test 3, and age we will keep it as it is. Now what we'll do is that we will iterate over these test cases. So we will write test case for each test case in test cases. We will write try block result, which is set to await insert into database validated. Then we will provide database path, which is set to database path. Then we will have table, which is set to users table. Then we will have data. We'll write test cases, data, and then we will have validate data, which is set to true. Now here we will write examples, append test case, and this will correspond to test case and the name of the test case. Then input data, which corresponds to the test case data. Then we will have result, which corresponds to JSON loads result. So this starts a try block to handle potential exceptions. And then we will call the insert into database validated function asynchronously with 4 parameters, which are database path that gets the database path. Then we have table, which will get the name of the table. And in this case, it is users. And then we will have data parameter, which is set to the data key of the test case. And then we will have validate data, which is set to true, which means that validation is enabled. The result is stored in a result variable. And then we will append the dictionary to the examples list. We will add 3 key value pairs, test case key gets the test case name, input data key gets the test data dictionary, and result key gets the parse JSON result using JSON load, using JSON load, which converts the JSON string back to a dictionary. Now for the try block, we will also write the exception block. So we will write except exception as E, and then we will write example append test case. We will write test case name, then input data, which is set to test case data, and then the error, which is set to the string of the exception object, which will give us the error message. So this catches any exception that occurs in the try block and stores it in the variable E. Now we will return the value. So we will write return JSON dumps, and then the dictionary type, validate examples. Let's say it is validation examples, and then we will set it to examples. After this, we will write note, and then this Examples show how the validation works with different data scenarios. We will write the indentation and it is set to 2. So with this, we have created our test validation examples tool. So this returns a JSON string created from a dictionary with two key value pairs. The validation examples key gets the examples list containing all test results, and note key gets a descriptive string explaining the purpose of the examples. Let's save this with Control S. Now we will create another tool called Update Database Tool, which modifies the existing records in a database table. So let's do that. We will write MCP tool and then asynchronous, define update database, then the first parameter, which is database path. It should be of type string. Then we will have table. It should also be of type string. Then we have data. This is of type dictionary. Its values are of type string. Sorry, its keys are of type string and values can be of any type. And then we have where clause. It is of type list and it can also be null. Then we have database type. This can be of type string. Its default value is set to SQLite. Then we have connection string and it can be of type string. Currently it is set to none and this tool will return a string type value. Then we will enter this tool. Now we will write the talk string. So let's do that. We will write update records in any database. Table. So this update database tool modifies existing record in a database table by changing the specific column values in rows that match certain criteria like updating a user's email address, changing product prices, or modifying employee salaries. And it requires a where clause to prevent accidentally updating all records. Now we will write database await and we will call the get database manager function. Then we will provide the database path, database type, and connection string. So this calls the get database manager asynchronously with the provided parameters and assigns the return database manager to the DB variable. The get database manager function implements connection pooling, which means it either creates a new database connection or reuses an existing one for the same address path, making the system more efficient by avoiding repeated connection overhead. Now we will use the if statement. First we will write a comment saying build update query with correct place holders, and you will write if database database type is SQLite. So if database is SQLite, then what we will do is that set clause join string column name the placeholder for column in data keys. So if it is a SQLite database, then this code will execute, and if it is a PostgreSQL, then what we'll do is set clause join string column name percentage or mod s for column in data keys. So this checks if the database is of type SQLite. For SQLite, this creates a comma separated string using list comprehension where each column name from database keys is formatted as like this column and the placeholder question mark. So each column name from data keys is formatted as this with the question mark placeholders. Then join concatenates them with commas. So the data keys contain the column names, and so what it does is that the data key has the column names. Let's say, for example, the column names are name, age, and email. So what this will do is that it will create a string like this: name, then question mark, age, and then question mark, then we have email. So it will create a string like this. So we have a column name which is equal to a question mark, and this question mark will be substituted to a value while executing the query. Now we have done the same for the PostgreSQL. In PostgreSQL, this creates a comma separated string where each column name is formatted as column and then mod or percentage s. Now what we will do is that we will create a query. So let's do that. We will write query update, then the name of the table, then we will write set clause where and the where clause, and after this we will combine data values and where parameters. So we'll write combine data values and where parameters. So parameters list data values. So we have got the values to substitute the placeholders, and if where parameters, then parameters extend here. So this constructs the SQL update query using app string formatting where table gets replaced with the table name, set clause gets replaced with the column assignments like name equals to placeholder like question mark, age equals to question mark, email equals to question mark, and where clause gets replaced by the where condition. Then this creates a list called params containing all values from the data dictionary. I mean the dictionary called data, and we have the values of it. So this creates a list called params containing all values from the data dictionary in the same order as the keys. And then the next line of code, this checks if where params exists and is not none. If where params exists, this extends the params list by adding all items from where params to the end, combining both the set clause parameters and where clause parameters. Now we will create a variable called result. We will add await database execute query. We will provide the query to execute. We will provide the parameters in tuple. So we will execute the query and then we will write result success. So if we have successfully executed the query, then what we will do is that we will return JSON terms status, which is set to success, then database path, which is set to PB path. Then we will have is sample database, which is set to is sample database path. Then we have message records updated in table, which is table name, and we will have affected rows from result affected rows. We will add indentation as 2. So this line of code calls the execute query method asynchronously on the DB object with the constructed query and parameters converted to a tuple. It will store the result in the result variable. The execute query method executes the SQL command against the database and returns the results. This checks if the success key in the result dictionary has a value true. If the query is successfully executed, then this will return the results. So this will execute if the query is successfully executed. And if it is not executed successfully, then what we will do is that we will create else and write return JSON dumps, and we will write the status, which is error. and then database path, which is set to DB path. Then we will have error, which is set to result error, and then indent is set to 2. And we have to add this inside the try block. So I will add try here, and for try block we have to create the except block, which is exception block. We will write exception as e, and then we will add return JSON terms status error database path db path variable, and then we will write error, which is set to string e, which is the object of exception, and then we will write indentation, which is set to 2. So this returns a JSON string from a dictionary with 3 key value pairs. Its status key gets the string error, database path key gets the data path variable, and error gets the error message from the result dictionary. This catches any error if it is present in the try block. Now we have created this tool successfully. We will create another tool called delete from database, which removes records from our database table. So let's do that. We'll write MCP tool and then asynchronous, define delete from database. Will provide the path of the database. It should be of type string, then table name. It should also be of type string, then where clause of type string, where parameters, which is of type list, but currently it is set to none. And then we have safety string, and it is set to strict. We have database type, and its default value as always is SQLite. We have connection string. It is of type string, but currently it is set to none. And we will correct this as well. This will return a string value. So this tool will return a string value. There is some mistake in this, so we have to figure out where that is. Yes, here. And then Now it is correct. So this creates a delete from database tool that removes the records from a database table with safety mechanisms, offering three safety modes: strict for preview only, confirm for preview with confirmation request, and force for immediate deletion, preventing accidental data loss. So this defines a asynchronous function delete from database with 7 parameters. DB path as a string for the database file path, table as a string for the table name to delete from, where clause as a string for the where condition, where parameters as an optional list with default null. This will contain the parameters for the where clause, safety mode as a string with default strict, controlling the deletion safety level, database type that is DB type as a string with default SQLite, and connection is string as an optional string with default null. This function returns a string containing the JSON response. Now we will create the talk string. So let's do that. We will write delete records from any database table. So now we will check two conditions. First, if the where clause is null, or if the where clause after stripping white spaces equals an empty string. So let's do that. We will write if not where clause or where clause strip equals to empty string. So if where clause is not present and after stripping the value of the where clause, it equals to the empty string. So what we will do is that we will return JSON dumps, then status as error. It is a string and not a variable. Then we will write database path, which is the DB path. Then we have error. It says that delete operations require a where clause for safety. Use where 1 equals to 1 if you really want to delete all records. So we'll provide the indent as 2. So if either condition is true, this returns a JSON string from a dictionary with three key value pairs. Status key gets the string error, database path key gets the database path variable, and error key gets a safety message explaining that delete operation require a where clause and suggest using where in which the 1 is equal to 1 if they really want to delete all records. This safety check prevents accidental deletion of all records in a table by requiring a where clause. Now, if it is not the case, then what we will do is that we will write try block, we will write db await get database manager, we will write db path, db type, And then the next thing, if it is for the PostgreSQL, you will write a comment saying first, always show what records would be affected. So preview query, select all from the name of the table where where clause. Then we will write parameters. It should always be in tuple where parameters. If where parameters else none. So this starts a try block to handle exceptions. And then we will call the get database manager asynchronously with the provided parameters and assigns the return database manager to the database variable, that is db variable. And then we will construct a select query using app string formatting where table gets replaced with the table name and where clause gets replaced with the where condition to preview the records that would be deleted. The preview functionality allows users to see exactly which record will be affected before any deletion occurs. And then in the next line, this code uses a ternary operator. If where param exists, it converts it to a tuple and assigns to params variable, otherwise assigns none. Now we will create a variable called preview result. So let's do that. We will write preview result await db execute query. Then we will provide the preview query and parameters. We'll provide the limit. So this will return the 10 rows or 10 records from the multiple records. And then we will write if not preview result success, then we will return JSON dump status, which is error database path, which is db path variable. Then we will write error, and this will have error reviewing records, which is preview result and the error that we have got. After doing this, we will give the indentation as 2. So this line of code calls the execute query asynchronously on the DB object with the preview query parameters and limit of 10 records, and then it will store the result in the preview result variable. Then In this line of code, this checks if the success key in the preview result dictionary is falsy. If the result query failed, this returns a JSON string from a dictionary where three key value pairs in which the status key gets the error string, database path key gets dbpath variable, and error key gets a formatted string that includes the error message from preview result. And if it is not the case, which means if we have got the result, then what we'll do is that we will write count total records that would be affected. So we will get the number of records that are affected. So let's do that. We will write count query select count. We will count all the records that we have got as count from table where and the where clause. After doing this, we will write count result await eb execute query. Then we will execute this query count query parameters and then fetch parameter which is set to false. And if we have not successfully executed this query, then what we'll do is that if not count result success, then I will return the JSON terms status, which is error database path, which is db path. Then we have error, which is set to error checking record count, and it is set to count record from error and indentation set to 2. So this line of code constructs a count query using add string formatting to count all records matching the where condition. The count query determines exactly how many records match the deletion criteria. The next line of code calls execute query asynchronously with the count query parameters and fetch all set to false to get only one row. So with fetch all set to false, we will get only one row and we will store the result in the variable named count result. Here it should be count result. And in the next line of code, what we are doing is that if the count query fails, this returns a JSON string from a dictionary with three key value pairs. And if it is not failed, then what we'll do is that we will write total records count result data, and then you will get the count. So this extracts the count value from the count result data by accessing the data key, then the count key, and assigns it to the total records variable. Now in the next line, we will write if total records are 0. So if the total records are 0, so what we will do is that we will return JSON dumps status as info for information, then database path which is set to TV path, and is sample database which is set to is sample database path. So this will check if the database is a sample database or not. We will write a message saying no records match the where clause criteria, and then we will write the number of affected rows, which is set to 0. Then we will have preview query, we will write indent as true. So this checks if total record equals 0. If no records match the criteria, this returns a JSON string from a dictionary with 6 key value pairs. And here it should be database path. Now, if it is not the case, which means that the total records are not 0, then what we will do is that we'll write prepare response with preview information. So we will write response data database path, which is db path is sample database is sample database db path. I will write table, which is set to table, and then where clause it is set to where clause. Then we will have total records to delete, which is total records. After that, we will write preview records. So here we will write preview result, and then data will only preview the 10 records, and then we will have showing preview of minimum of 10 or total records. So this creates a response data dictionary with 7 key value pairs. Database path key gets database path. Is sample database key gets the Boolean result from is sample database function. Table key gets the table string. Where clause key gets the where clause string. Total records to delete key gets the total records count. Preview records key gets the first 10 records from the preview result data using slicing notation, which is 10, and showing preview of key gets the minimum of 10 and total records using the mean function. This response data structure provides information about what the deletion operation would affect. Now we will handle the different safety modes. So we will write handle safety modes. So we will write if safety mode is strict, then response data will be updated to status. Preview only. Then we will write the message preview total records. Will write records would be deleted. No actual deletion performed. So we have not performed any deletion operation. And in the next key, we will write next steps, which says that to safety mode, which is set to confirm or safety mode, which is set to force. Then we will return this response data. So we will write JSON dumps response data. Indentation is set to true and default is set to string. This checks if the safety mode equals the string strict. For strict mode, this calls the update method on response data dictionary to add 3 more key value pairs. Status key gets the preview only string. Message key gets a formatted string showing how many records would be deleted with no actual deletion. And next step key gets instruction on how to proceed. This returns a JSON string from the response data dictionary with 2 space indentation and default is set to string. The strict mode provides maximum safety by only showing what would happen, and then the strict mode provides maximum safety by only showing what would happen without performing any actual deletion. Now we will write the else if condition. So else if this safety mode is confirmed, and if it is confirmed, then what we will do is that we will update the response data. So let's do that. Response data update status awaiting confirmation message have string confirmation required. This will delete total records, and in the next line we will write the warning key which says this action cannot be undone. Then we will write to proceed, call this function again with safety mode is set to ports to execute the deletion. Then we will have to cancel key which is set to take no further action to cancel the deletion. After doing this, we will return JSON dump response data indent is set to 2, default is set to string. So this checks if safety mode equals the string confirm. For confirm mode, this updates response data dictionary with 5 more key value pairs. Status gets awaiting confirmation string. Message gets a formatted string requiring confirmation for the deletion. Warning gets a string warning that the action cannot be undone. To proceed, key gets instruction to call with safety mode, which is set to false, and to cancel key gets instruction to take no action to cancel. This returns a JSON string from response data with formatting and default string conversion. The confirm mode shows the preview and explicitly asks for user confirmation before allowing any deletion to proceed. Now, as we have done this, we will write another else if condition which is set to false. So let's do that. We will write else if safety mode is set to false. We will add a comment saying additional safety check for sample database. So we will add a safety mode for the sample database. So we will add the safety mode for the sample database. So the deletion operation cannot be performed on the sample database, but it can be performed on any other databases. And instead of sample database, you can use any other database that is important and you do not want to delete any record from that. So you can use that database in this. For now, we are using the sample database. So we will write if is sample database. We will give the path. So with the help of path, it will determine whether this is a sample database or not. And then we will update the response data update, and we'll write status as warning, message as deletion from sample database, block for safety. Then we will add note sample database is protected. Use a different database for testing predictions. We will return JSON dumps response data. Indentation is set to 2. Default is set to string. And if it is not a sample data, then what we will do is that we will write execute the actual delete. So we will create a delete query. Type string delete from table name where clause, and then we will write delete result await database execute query delete query parameters allow delete set to true. In this code, this constructs the delete query using app string formatting where table and where clause get replaced with the table name and the where condition respectively. And in the next line, this calls the execute query asynchronously with the delete query parameters and allow delete which is set to true to enable delete operations. And this will store the result in the delete result variable. Now we will write if delete result is success, then what we will do is that response data update status is set to success, message is set to successfully deleted with result affected rows, and then we will add records from table, which is table name. Then we have affected rows, which is set to delete result. Affected rows, and then we will return the JSON dumps response data. Indentation is set to 2. Default is set to string. And then we will add the else statement if here it should be success. So here we will add the else statement. And if the condition does not match with any of these safety modes, then what we will do is that we will write response data update, and the status will obviously be error. The error message, delete result, error. And that is it. We will return this prompt response data, indent is set to 2. So if the deletion is performed successfully, then what will happen is that this updates the response data with 3 key value pairs. And if deletion is failed, that is in this case, then what will happen is that this updates the response data with 2 key value pairs. Status gets the error, and the error key gets the error message from delete result. Now, this else statement should be aligned with this if statement. So this else statement is not for the condition where it does not match any of the safety mode. So this else statement is not for the condition where it does not match any of the safety modes. This is for the condition where if the delete result is not success, then this will execute. And now we will create an else statement for the condition where it does not match any of the safety modes. So let's do that. So this is the else if, and here we will write else, and then we will return JSON dumps dictionary where status is set to error, and then database path is set to tb path variable. Then we have error saying invalid safety mode, and the safety mode that is provided as a parameter. We will give more information, use strict, confirm, or for. And after doing that, we will write indent, that is 2. Now for the try block, we have to give the exception block as well. So we will write except exception as E, and then we will return JSON dump status as error. This should be a string, and then we will have database path, which is db path, and finally we will have error, which is the string of the exception object. Indent is set to true. So this handles any safety mode value that does not match strict, confirm, or force. So this will return a JSON string from a dictionary with 3 key value pairs. This concludes part 5 of the database MCP series. Today, we built a validation testing tool that demonstrates our data integrity feature through real-world test cases, showing how our validation system handles valid data, empty fields, null values, missing required fields, and white space only entries with detailed examples. We developed an update tool that safely modifies existing database records with proper parameterized queries, support for both SQLite and PostgreSQL, and error handling that reports affected row counts. We implemented a multi-layered delete system with 3 safety modes: a strict mode for preview-only operations, confirm mode for explicit user confirmation, and force mode for immediate execution, along with a dedicated preview tool for safer deletion operations. In the next part, we will implement database inspection and connection management utilities, including tools to explore database schemas, manage active connections, and provide database information for better operational awareness. If you need help with your projects, have difficulty learning these concepts, or want to deepen your understanding of how things like this work, Codersarts is here to support you. We offer personalized project assistance, one-to-one live sessions, help with building AI-related applications, and full development and deployment services. Visit us at www.codersarts.com or reach out directly at contact@codersarts.com. You will also find our LinkedIn, Instagram, and Facebook handles linked in the description box below. Thanks for watching, and don't forget to like and share the video and subscribe to the channel so you never miss out our latest tutorials. Thank you.